On your synthetic divisions worksheet, flip it over to the back page, and there's some room at the bottom. Let's go. Here's my back page. That's number 10. Look at all that space on the bottom. We're going to first divide that space with a line. Divide that space with a line. We're going to do some practice. Before we jump into synthetic division. We're going to do two problems. Given the zeros, we're going to write the standard form of the quadratic. Given the zeros, we're going to write the standard form of the quadratic. If your end of year stage test is anything like it was last year, this was very common of you working backwards. We've practiced for weeks now going from a quadratic and factoring and solving it, and you all know the zero property. You all know how to solve it. We also need to go up the scale. Okay, so we're going to, here and there, we're going to keep practicing lots of these. You did some on your homework that had complex numbers. Today we're just going to do the simple version, because that's probably more of what you'll see on the test. If I give you the zeros, 1 and 4, both real numbers, so it's going to be really nice. There are two zeros, which means it has to be a quadratic, because a quadratic is degree 2, right? And we know that with the fundamental theorem of algebra, whatever a function with degree n, a polynomial function degree n, has to have n zeros. It has to be the same. Do either one of these have conjugates? No, because that happens when they're complex, right? These are both real, so they don't have to have a conjugate. Okay, so let's write our function. If we're going up the ladder, we're down here, we know the zeros, we have to go to the factors, then we get the standard form. So if we have the zeros, what would the factors be? Okay, that was a lot of talking. What was it? Caitlin, you with us? Have to be different signs. If that was positive, it would be minus. If that was positive, this one will be minus. And don't forget the x. Then your last step is to do what we just did on our review problem. Times them through. Can you do that? Find your like terms, times them through. I think you can do that. Can we flip over your worksheet, please? Where we separate that in half, draw a line. Horizontally. No, other way. Horizontally. Okay, and write that. Okay, and find your like terms. Since we're doing a binomial times a binomial, you should get a string of 4, and then you'll have some like terms to add together. Because the zeros have opposite signs of the factors. So this was a positive one, so the inverse of the positive is minus. Oh, okay. Inverse of this positive is minus. Oh. Okay? Good, now find your like terms, put them together. All right, Derek, what did you get for your final polynomial? Okay, listen up, please. Shh. I'm sorry, still some people not paying attention. X squared minus what? Okay. Good, I agree with that. If you made it to that point, you're good. Because in the middle, you should get a negative 1x and a negative 4x. Okay, let's try one more. Example 2. Same thing, I'll give you different zeros though. Remember, these can also be called roots. They can also be called solutions. They can also be called x-intercepts. How about negative 3 and 8? I want you to go through the whole process. Go back up the ladder. If you have the zeros, you need to write the equation. You go from zeros to factors to standard form in the equation. Make sure you have an f of x equals in front, or a y equals. You need one of those. When you think you're done, share with your neighbors if you guys are getting the same. Make sure your factors are the same, and your standard form is the same. Good. Yeah?
Okay. Let's see. Alright, I have to so how do you tell whether it's like x minus or whatever?
There will be an x, because the binomial will have an x. And then you do the opposite sign. If this is -3, you do plus. Okay? Alrighty! Kayla, what were the factors you got, please? And? Good, because they should be inverse signs. This says minus, we write plus. If this says 8, positive, we say minus 8. And then you multiply them through. You should get x squared. We get a -8 and a +3, which makes -5. X, and what's 3 times -8? -24. Okay? So, once in a while, we're going to hit those because I saw a lot of those on the test last year. Will you flip over to the front side now? We're going to learn this new thing. How is the... Oh, it's my marker. I thought that came out of my hair. That was weird. The marker's falling apart. We're going to do synthetic division. Who knows how to do long division? Long division, I think you learned in 4th grade. I remember Mrs. Matthews taught me long division. She was my 4th grade teacher. So I'm thinking it's a 4th grade thing. We're going to do long division in a way with polynomials. I'm going to show you number 1 long division style. We're not doing it this style because this method gets a little messy sometimes. So in division, you have this box, right? Actually, maybe I'll do it here because I am recording a video. In division, you have this box. What goes outside the box? The number you're dividing by. In this case, it's x plus 2. And then the dividend, 3x squared plus 7x plus 2 is there. So we want to get them to match. X times what would be 3x squared? Yep. So I'm going to put in the x column. X to the first column is right here. So x times 3x is 3x squared. And I have to do 2 times 3x is what? Positive 6x. Now with division, this row we then subtract it, right? So I'm going to subtract and subtract, which cancels that out, which is what we want. 7 minus 6 makes 1. X, I bring down my plus 2. Now I need to get them to match. X times x, or x times what is x? 1. That's a positive 1. So x times 1 is x. 2 times 1 is 2. And then I have to subtract them. Subtract, subtract, I cancel out. And I get 0. And that's really important today to get 0. When the remainder is 0, that means this guy was in fact a factor, meaning x equals -2 is a root or an x-intercept. As long as the remainder is 0, it means it's actually an x-intercept. Okay, that's the long division version. We're going to do a simpler one so we don't have to worry about the variables and making sure the variables are all good, called synthetic division. And we'll get the same They'll get the same answer. So, you didn't have to write that one down. Okay, we're going to look at number 1. If my marker will cooperate. It's always the red that doesn't cooperate, so I'll go with purple. Okay, our factor is x plus 2. This is a factor. The tricky part on synthetic division is to make sure we're going to put inside of a box the 0 or the x-intercept. If the factor is x plus 2, what's the 0? Negative 2. So those have to have opposite signs. And then all we're going to do is write the coefficients in order, but we have to make sure there's no gaps. This goes x squared, this is x to the first, this is x to the 0, so we have no gaps. There's 1 representing each place. So we're just going to write the 3, the 7, and the 2. And then leave a line of space. I need a line of space because I'm going to be writing stuff in there. This is how synthetic division works. You add the columns. So there's nothing below the 3, so I'm just going to carry it straight down. And it's 3. You add the columns, and you times diagonally. When I go up diagonal, I'm going to times by my guy in the box, my 0. 3 times negative 2 is what? Negative 6. And I add my column, and I get 1. Diagonally, I times by negative 2. We'll do it a couple times, and you'll see it's actually really fast. 1 times negative 2 is negative 2. I add my column, and I get 0. When that is a 0, it's good. It means this is actually an x-intercept. Now, each one of these numbers at the bottom represents something. This is your remainder, and then we work backwards in standard form. This is your constant. This is your x. And then if we had another one, that would be x squared. If we had another one, it would be x cubed, x to the 4th as you go to the left. So we got 3x plus 1. Is that what I got on this version? Yeah, it's the same. And this is actually an easier process. Okay, let's try number 2. The more you see it, the more comfortable you'll get with it. But remember, this is a factor. That is a factor, x plus 5. Okay, they're here. The team up. Let's see. Okay, factor is x plus 5. Could you show me fingers in the air, please? What's the 0 if the factor is x plus 5? Good. What is the 0? If the factor is x plus 5, what's the x-intercept, or the 0? It's opposite sign. So, Caitlin, what's the opposite sign? Negative. So we write negative 5 in the box. Before I start writing down numbers, I want to make sure every place is represented. X squared, x to the 1st, the constant. Are there any gaps here? No. And they're in order. They have to be in order. There's a problem later on the bottom of the page, so they're not in order, so you have to make sure they're in order. Okay, so I'm going to write my coefficients. 2, 7, and if I just write 15, what's wrong with that? It's negative 15. Leave a gap for our work. Okay, you add up the columns. Starting with the 2, there's nothing below it, so I just bring it straight down. Okay, what do I do diagonally? Times by negative 5. Depika, can you help me out? What number do I put here? Good. And Depika, what number? That's a 10. 10. What number do I put here? Add. Negative 3. So we add the column, then we multiply diagonally by the number in the box. Negative 3 times negative 2. Positive 15. Now if I add my column, I get 0, which is good. You want to get 0. Oh, sorry, I looked too far. It was this one. I probably looked at the last example. If we get 0, it means it's actually an x-intercept. Like math chaos in the back. I'll let them discuss that for a minute. All of a sudden we got really excited back there. Okay. Learning, it's fun, huh? This is our remainder. Let's write down what we get when we divide out. -3 is a constant. Instead of, usually we read like a book, but this time we're reading backwards. Okay, I would start at the constant, -3, and what do I put by the 2? X. X to the first power. And if you notice, both of these started as quadratics. Once we divided them, the power was decreased by 1, and we get a linear function. If we start with a cubic and divided, you would get a quadratic. And divide again, you would get a linear. Divide again, you would get a constant. So the power should be decreasing. Let's try this one at the bottom, number 5. Okay. Remember, this is a factor, so you have to make sure you're setting it up correctly. Before I start drawing my box, I can already tell this is not in order. Brindy, can you tell me the correct order of my polynomial? What is the sign, though, for x to the 4th? What's the sign of x to the 4th? Negative x to the 4th. Okay, and then? Okay, so let's say that right. Negative 2x cubed, or you say to the 3rd power. Okay, and then? Good. Good. Okay, first I'd make sure it's in order. Are there any gaps? 4, 3, 2, 1, 0 on the powers? If there is a gap, you just put a 0 for that gap. Okay? So, in my box, here's in the air, please. What's the 0 or the x-intercept if the factor is x plus 2? It should be, good, it should be minus 2. And then we just write down the coefficients. What's the coefficient here? -1. Good. -1, -2, 3, 4. You want to leave some space in between them, just so it's not so squishy. You want to try this one by yourself? And then we'll check, see how you did. Yep, I'll go through it when you're done. I'll try it by yourself. Hmm? Oh, you're already done? I don't remember what my answer was. Come look at your work. Okay? What? That's fine. We'll write the answer. Okay? Good. Yep. This one, when you write your answer to barley pretzel, you just write remainder 15.
Oh, okay. Thank you.
Okay. Let's see, I already looked at hers, so I don't want to have to look at it again. Let's just see if it matches. Yes. Okay. About 30 more seconds, and then I'll... Okay, so pull that straight down. You add up the columns, so there's nothing underneath it. So underneath the line, you just put -1. Okay, now you multiply up to here. So I do a little arrow. And take this number times this number. Okay, then you add up the column. Good, and then -1 or -2 times 0 will go up here diagonally. Good, add up the column. Then diagonally, what will go there? Good, add up the column. -2. You'll be finishing it. Okay? Good. Alright, I'm going to just go through it really quick, check what you got, see if it's the same, and if there's an issue, we'll clarify. There's nothing underneath the -1, so I pull it straight down. -1. I times by my box, which I get +2. I add, I get 0. I times by the box, which is 0. 3 plus 0 is 3. I times by my box and get -6. I add and get -2. Times by my box and I get +4. Add and I get 0. Now, if you've already done one of the ones that the remainder isn't 0, it's okay. When you write it out, you just put remainder, whatever the number is. Remainder 0, which we don't really have to write. But if there is a remainder, you just put remainder, whatever the number is. The -2, I work going to the left. What do I put with the 3? X. What do I put with the 0? X squared, but we don't really need to write 0x squared. So the -1 goes with an x cubed. And because we also don't need to write remainder 0, I'm just going to box that section. Anyone have a question? Yeah?
What power it goes to?
You just work backwards. This one is always the remainder. This one's always the constant. This is always the linear. X squared, if we had more, would go x cubed.
Oh.
Yeah, you just keep increasing the power as you step to the left. Okay? Yeah? You do count the x squared, but it was a 0, which is why this one stepped it up to x cubed.
So negative x plus 3x.
Oh yeah, there is a plus sign. You're right. Plus. Okay, so we're going to be using that synthetic division on something else here in a minute. So your homework is to finish that worksheet. And then we're going to have a couple problems that are a little more difficult, like the ones that we're going to do here in the book. So would you find a piece of paper? This again comes from your honors section. There's a little bit we still haven't covered. And on your paper, label it this following. We're just going to do 2. Just 2. And whatever time we have remaining after it, we can go over a test review. Your test review has all the answers on it. Just a word of warning, the test review does not have anything on these honor sections, but there will be stuff on your test from the honor sections. So this homework, honors 35 and honors 47, make sure you've done the homework so that you're prepared for the section on the test. The test is on Tuesday for you guys, right? After this example, I'll give you a break before we do the last one. Nope, we're doing it right now. The title, it's kind of long. Finding real or complex zeros of polynomials with degree n greater than 3. If it's a linear degree, x to the first, or x squared, sorry, even x cubed, we have ways to find those zeros by factoring by grouping. Once you get to a degree higher than 3, it's a little more complicated. Essential question. Explain how to find the zeros of a polynomial. Explain how to find the zeros of a polynomial with degree n greater than 3. When you are not given any zeros. Explain how to find the zeros of a polynomial with degree n greater than 3 when you are not given any zeros. Okay, we're going to find the zeros and write what's called a linear factorization. All that means is we're going to write out all the factors, and they're linear because they should be x to the first powers in an equation. Once you have that written down, if you do not have a graphing calculator, please go get one. Alrighty. Also remember, on test day, all your notes are due, so that on Tuesday, you'll need to bring all of your notes. Next time in class, we'll probably work on compiling them, but keep that in mind. On the test? Guess you'll have to study and decide if it looks the same or not.
I didn't know it was I worked it all out.
Good.
I found out that it was came out like really.
Okay, so this function right here is a fifth degree. Who knows how to factor that? Anyone? Anyone? Bueller? Bueller? Have you seen Ferris Bueller's Day Off? Okay. Yeah, I don't even know how to factor that by hand unless I have a hint as to what zero to try. So this is where your calculator comes in handy. We are going to graph this and look at the graph and try to predict some zeros to try out. And we'll use synthetic division to verify if they are true x-intercepts. So would you go, please, to your y equals, sorry, I'm doing like two things, I get confused. Go to your y equals button. What? Okay, turn your calculator on. Go to y equals and type in this that you already put on your notes. Have you written this down? Write this down because I'm going to need Aruna to tell me because I can't see both screens at the same time. I guess I can do it while you guys are writing down. X to the 5th minus 3x to the 4th minus 5x to the 3rd plus 5x squared minus 6x plus 8. Come on. Bring it over here if you would. Okay, make sure that's written down, then go to your y equals button and type it in. Okay, I'm going to have mine on the camera now. Whoa. I've never seen that before. That's strange. I just pushed clear and it went away.
Oh, really?
But hopefully it doesn't do that again.
Oh, I've been doing that for a few days.
Yeah, I just arrowed over and pushed clear. So hopefully it's okay. Unless your calculator has a virus. It probably could be if you connect it to the internet and download something. Okay, so when we graph this, oh, I'm in a funny window. Let's see, if I go to let it try to graph, see that scrolly thing in the corner? That means it's processing.
Wait, which side of that?
Yeah, you have to go to y equals and type in the function. Okay, now if I go to zoom standard, a normal graph, let's see where it crosses the x-axis. Oh, it looks like we have at least 3 points, right? Let's take a guess as to what those 3 points are. Maddie, what do you think our x value here is? Maddie, yeah. X equals, there's the origin, I'll get something pointy. Here's the origin, 0, 0, so what's this x value? That's the origin, so what's this x? Now this is 0, so -1, this would be -2. Okay, so would you guys write that down on your paper? This is one we're going to try. These are possible solutions. X equals -2 is a possible solution. Cindy, what's this possible solution right here? X equals 1 looks like a possible solution. And Kyler, what about this one out here? X equals 4. Write those on your notes, please. X equals, we're going to try -2, we're going to try 1, and we're going to try 4. Okay, I'm going to come to the board now. Possible solutions or x-intercepts or zeros or roots. X equals, oh, what did we say? -2, 1, and 4. Is that it? Okay, so we can tell if they're actual intercepts by using synthetic division. So I'm going to start with the -2. I put the -2 in the box. Because it is a 0, we don't have to change the sign. It's when you go from a factor to the box that you have to change the sign. Are there any gaps in my powers? Always look for that. No. So we're just going to write down the coefficients. Dan, can you read out the coefficients I should write down? And by the way, we need some space. Okay, so leave some space. Yeah. In order. Coefficient of x to the 5th. 1. Uh-huh.
5, 6, 8.
All right. Leave a line of space. Put a not so straight line underneath it. Okay, and let's do synthetic division. We carry down the 1. Kevin, what do I do now? Good, so I get -2. Add up the columns. I get -5. Multiply by -2. I get 10. Add up the column. I get +5. Multiply by -2. -10. Add up the column. Multiply by -2. +10. Add up the column. 4. Multiply by -2. Add up the column. So what does this tell us if we get a 0? It is actually a root, an x-intercept. If we don't get 0, it could have been because the x-intercept was like -2.1. Maybe it just was so close, it looked like it was on -2. If we wrote this out, I'm going to do it on the side here. The remainder is 0, which we don't need to write. I start at the 4, it's a positive. What comes to the left of the 4? -5x. 5x squared, so we increase the power. It's a positive 5x squared. What comes after that? 5x cubed. And then lastly, positive x to the 4th. So notice now it went from the 5th degree, now it's a 4th degree. So we have 1. Will give us a nice little check. That works. Let's try 1. Now you don't have to use the 5th degree. You've made it to the 4th degree. You can use a smaller polynomial. I'm going to plug in our next possible solution, 1. I'm going to do synthetic division again. You can do the 5th degree if you want. It's just more work. We have a simplified form right here. I'm going to carry down those numbers I just got the row above. And I don't need to use the 0. And do synthetic division again. Everything but the 0. We're trying a new root. This one we tried -2. Now we're dividing again, which will give us, we're looking at the root x equals 1. Because we want to find all roots. And since it is a 5th degree, we know that there has to be 5 roots because of the fundamental theorem of algebra. Give you a sec to finish that, and then I'll show you what I get, and you can check, make sure you do it the same way. Okay, you're back? Yeah, you can keep it. There's a worksheet on your desk that we started. The rest is homework, and we're now doing notes, and this is all recorded, so you can catch up at home. Okay, so we carry down the column. You should have got 1. Times by 1, we get 1. Add the column, we get -4. Times by 1, we have -4. Add the column, we get 1. Times by 1, we get 1. Add the column, we have negative 4. Times by 1, we get negative 4. And we get 0. What does that mean? It is actually a root. So we found 2 of the 5. There should be 5 of them. Okay, now this should be a cubic. We have a negative 4, 1x, positive, negative 4x squared, and a positive x cubed. It's now cubic. Each time we divide, it decreases the polynomial by 1 more term because we've taken off that root we found. We're working with a smaller polynomial. We have to keep doing synthetic division until we get down to a quadratic. Our last one to try was it a 4?
Yes.
Yeah. And I want to use the trinomial. You can do it again to the 5th degree. It's too much work though. Let's use the 3rd degree, not the trinomial, the 3rd degree. Do synthetic division on that one. Okay. Actually, let's do this. Dylan's been gone. Who can teach him synthetic division? Okay, come up to the board and explain, please. Yep, with my marker. What's this? Is this the x cubed graph?
Go with the first graph that we did.
The big equation on the board.
Yeah, the problem on the board.
Okay. So your 0, like 4. Then your graph is down. That would be 1. You times the 1 by 4. So it's 4. Then you drag those down, you add them. So it's 0. And 0 times 4 is 0. Drag the 1 down. Times it again. It's 4. 0. You can still do it right here.
We'll do it more. The more we go over it, the easier it becomes. But first they're complaining. And now some of them like it. Few of them. Okay, so since this is 0, it verifies, thank you, by the way. It verifies that 4 is the root. So we found 3, but there has to be 5. Once you get to the quadratic, you can keep going. But with synthetic division, if you so wish, but we only found 3 on the graph that we knew could be possible solutions. We should know how to solve this quadratic looking for zeros, setting this equal to 0. Do we know how to solve quadratics? I think we do. We have options of square roots, we can factor, we can complete the square, we can do quadratic formula. What's the easiest way to solve this one? Complete the square, really? Wow. No, this one, since there's only one x term, I would just solve it straight out, inverse operations, and take the square root. I go minus 1, x squared equals negative 1, square root. Now, what is the square root of negative 1? What is it? Plus or minus? What's the square root of negative 1? I. And these are conjugates. Whenever we have imaginary solutions, they have to come in pairs. So we have a positive version and a minus version. So we had all of our solutions our solutions are zeros we got where x equals negative 2, we checked that one off. 1 worked, 4 works, and plus and minus I. How many in total did we find?
5.
And that's exactly how many we should get because it's a 5th degree. Now the linear factorization is really easy to write down. Linear, because it asks for linear factorization as well. Linear factorization means take these zeros and write them in the function as factors. We've been practicing this on the board, going backwards. I'll let you write that down. Linear factorization. We need an f of x or we need a y. If the x is negative 2, what's the factor? I need a little more than that. It's a binomial. X plus 2. If the x is positive 1, what is the factor? If we have 4, x minus 4, then we have x minus I, and those come in pair, x plus I. This is the linear factorization, okay? We will take a quick drink break. We have one more like this to try. But if you're in the hallway, and especially when you're around the drinking fountain, please don't be really loud and obnoxious. If I can hear you when I'm 15 feet away, you're too loud. Okay? Please be respectful of other classes. Okay, one more. Now this one, when we write it out, we definitely need to like space things out or you're going to run into some spatial issues. Hurry, ladies.
I know, same here.
Yeah. Well, plan on this one being like that too. That's why we're only doing 2. Okay, if you are, that's actually a really good point. You probably want to flip your page over to the back. If you're still on the front side and that took a good chunk of your space, you probably want to flip over to the back. The complex number z, remember we called z complex number before? 1 minus 2i is a 0, or an x-intercept, of this function. Right? Find all zeros and write the linear. I'm missing an r apparently. Linear factorization. This time they gave us one helpful hint. Okay. Gabby, how many x-intercepts or zeros in total should we be looking for? 4, because this highest degree is a 4. Now those can be real, or they can be complex, or they can be a mixture of both. They've given us one complex, and we know, because we have a theorem, that these come in pairs. So if z is this one, z bar, there's another one that we should already know about. If one is 1 minus 2i, what's its conjugate? Alicia, put the phone away, please. 1, what was it? 1 plus 2i. So now we know 2 of the 4. Because we understand conjugates. And that each complex 0 will have a conjugate 0. So, we're going to use synthetic division to divide these out. Okay, false alarm. Let's start with the one I just wrote. 1 plus 2i goes in the box. Now, I'm telling you right now, when you write out your coefficients, leave room. I'm going to write the 4. I'm leaving room. Like, seriously, we need room. Maybe a little more room. There's only 4 of them. Seriously, we need room. Space those out a lot, or you're going to run into trouble. Yeah?
If that's 17 squared, then wouldn't you have to put a 0 in? So we're
Yes, actually, thanks for catching that. She is correct. We have a 0, because we're missing the x cubed. And the 17. Okay, leave a line of space. Okay, it is the same as before. We just have, when we're multiplying by a complex number. So we pull the 4 straight down because nothing's underneath it to add. Then what do I do? Times it by that. So 4 times 1 is 4, and then we do the imaginary piece. 4 times 2i is plus 8i. Now we add them up. The 0 is a real number. 0 plus 4 is, so 4 plus 8i. I'm going to put that in parentheses so I can remember separations of what belongs in each place value. Now we times this complex by that complex, it means I need 4. That's why we need space, and we get 4 terms. So 1, okay, 1 times 4, and put parentheses is a 4. 1 times 8i is a positive 8i. Now I'm going to go to the 2i and distribute it in. 2i times 4, a positive 8i, so we have some like terms right there. 2i times 8i is plus 16i squared. Okay? We have real parts and imaginary parts. For the real parts, these are like terms. 4, and isn't 16i squared a real number? Because I squared is negative 1. So this becomes negative 16. Okay? So 4 minus 16 makes negative 12. And then we have the imaginary parts, 8 ice creams plus 8 ice creams, 16 ice creams. Oh, we didn't add, we do have another real piece, you're right. Thanks. The 17 plus the negative 12 makes negative positive 5, yeah. Good catch. Whew, it's been a long day. So fun. Okay. Let's do it again. Okay, now we're taking this complex number and times it by our complex number in the box. 1 times 5.
5.
So I'm going to put parentheses to separate these. 1 times 16i. Now we go to the 2i. 2i times 5. 10i. 2i times 16i. Positive 32i squared. I forgot the squared. Okay. The real parts. This is 32i squared will become what number, Jennifer? Negative 32. So we have 3 real parts. I'll remember all of them this time. Negative 32 plus 5. Negative 27 plus 14. Negative 13. So we put the real part first and then the imaginary. 16 ice creams plus 10 ice creams is 26 ice creams. Yeah, it's like Dan's freezer. Okay, one more. Gearing up for this. Okay, 1 times negative 13 is negative 13. 1 times 26i. Okay, then we need to multiply 2i in. 2i times negative 13 is negative 26i. Look! Cancel, cancel. 2i times 26i. 52i squared.
Yeah.
Yep, we can set it over here. What does 52 become? Negative 52 minus 13 is a negative 65. And look, positive 65. We get 0, which means that that is actually a 0, which we should get because they told us it was a 0.
What did we do all of that then?
Because the directions are right, the linear factorization, there are 4 zeros. We only know 2 of them. We have to find the other ones. Guys, don't worry. This next one's better. Look, it's going to be magically be so pretty.
I
We have the conjugate. You guys are such complainers. We have to do it one more time. Leave space, but I promise you this one's magically going to be prettier. 4. You guys are huge complainers. Man. First you love synthetic division, now you're like, torture.
I got tortured by long division, now this.
Okay. It's going to be okay. Okay, carry down your 4. Look, you're going to see it instantly. It's so much prettier. I'll even use pretty purple. Okay, carry down your 4. We multiply. 4 times 1 is 4. 4 times negative 2i. Look at the imaginary pieces. Cancel, cancel, and we get a pretty 8. Oh, pressure relieved. Look how pretty that is. Pressure relieved, like, because you guys are freaking out. It's okay. 8 times 1. 8 times negative 2i. Look how pretty. Magic. Oh, so much better. 13 times the 1. Now you like it. 13 times negative 26i.
I like this one better than the other one.
Okay, so we get a 0, which is good because they told us it was a exit or a 0 or a root. So if we don't get 0, we've done something wrong because we're supposed to get 0 if it's been told to us it's a 0. Okay, well let's look at these pretty numbers. This is 13 plus what? 8x plus. Once you become a quadratic, you can just factor it if it's a nice one. I'm going to tell you right now it's not. So if it's not a nice one, your 2 options are quadratic formula or completing the square. Which would you like to do? Everyone likes quadratic formula. But it has to be equal to 0 for quadratic formula. Yes?
Do you have negative, or no, 1 minus 2i, how can we distribute to both of them?
I took this number and times it here. 8 times 1 is 8. 8 times negative 2i is negative 16i. Okay. Good. Alrighty. We need our A, B's, and C's in order to do quadratic formula. Quadratic formula will be on your test, so this is good review. Let's hear it from Brandon. What's A? What is A? B? Okay. Alright, we're going to sing the song so we remember the formula. X is, actually I'll just fill it in as we go. X equals, it's negative B plus or minus square root B squared minus 4AC all over 2A. Okay? On your test, there will also be questions about the discriminant, which is the first thing you should start working with when solving a quadratic formula. You need to find out what's that number underneath the square root. If it is positive, we get 2 reals, because we can take square roots of real numbers. If it's positives. If it's negative, we get 2 imaginaries. If it's equal to 0, you get 1. What's the discriminant? I don't think it's 8. What is the discriminant? I don't think it's 8. I think it's negative 144. That sounds correct. Yep. The discriminant, meaning underneath the square root, negative 8 plus or minus square root of negative 144. And 2 times 4 is 8. No, you can't. It's a very good question. Because you can only cancel when neighbors are being multiplied. Lots of people try doing that, and you can't do that. Square root of negative 144. Since it's a negative, we know we're going to get two imaginary solutions, which is why we couldn't factor. Good. Yeah, the square root of negative 144 is plus or minus 12i. Now there are two pieces to this. We have a real piece, which is negative 8 over 8. And we have an imaginary piece, and this is where people get it wrong. They'll just go plus or minus 12i. It's still a fraction. They both have the denominator 8. So we have two answers. Negative 8 divided by 8 is, actually I don't need to do this little arrow. I can just put equals because they're going to be the same, except for different signs. Negative 1 plus or minus 12/8 simplified. Daniela, what's 12/8 simplified? You have to divide by 4. Well, 3 over, oh, you're right. I'm sorry. Sorry. Okay? These are two answers because of the plus and minus. They're conjugates because they're exactly the same except for one is plus and one is minus. So, what? Nope, we already know. We use quadratic formula, so it works. So we have 2 here. Wait, we're not done. We have to write linearization. 1 here, that makes 3, and 4. Make sure you have all of them. It's a 4th degree, and we have 4. We're going to write, calm down. We're going to write the linear factorization now. Our x's that we found was 1, can't see all of them. 1 plus 2i, we found 1 minus 2i, we found negative 1 plus 3/2 I, and negative 1 minus 3/2 I. In this case, they're all imaginaries, which means it never actually crosses the x-axis. Because anything to the even power is shaped kind of like a parabola, and so it's either all above or all below the x-axis. So let's write the linear factorization. Okay? This is a positive 1, so we do the opposite of that. So we go x minus the group 1 plus 2i. Group that. Then we have another positive 1. So we write, instead of plus, we write minus the group 1 minus 2i. Now the next one, x. This is a negative 1, so we write plus the group negative 1 plus 3/2 I. And then we have a negative 1, so we write x plus the grouping of negative 1 minus 3/2 I. And that is your linear factorization. You're going to have 8, 2, 4, 6, 5 problems off of this book section. 1 second. So, your homework tonight is to finish your synthetic division worksheet. We have 6 problems that are like this. We're doing the evens. We're doing another part on H47. And you can ask questions on this next time. Even. And then we have a test review, which I've given you all the answers to. I'll pass out here in just 1 sec. We have tutoring after school if you want help on the test review or any other questions, or you need to redo your factoring test. The last page of this has the answers for your test review. There should be no surprises on the test. Make sure you take one and pass them down, please.
Because I want it.
Did you get homework? Ashley, test review. Make sure you have a test review before you leave. Oh, sorry. Give one of these to Brandon. Make sure you have a test review before you leave. We'll have questions on the test review and those 6 problems if you have questions next time.